We're now going to take a look at trigonometry for right-angled triangles. Understanding angles. Now, you already understand that there are 360 degrees in a revolution, and degrees are shown with a symbol, sort of like a superscripted 0. Each degree is divided into 60 minutes, and minutes is shown with a single little superscripted dash. Each minute, as with time, is divided into 60 seconds, and the minutes are shown with a double dash. Okay, let's continue with looking at and understanding our angles. When rounding angles to the nearest degree, 0 minutes to 29 minutes do not change the degrees. It's less than halfway. It's the same sort of thing that if you have 3.4 meters and you're rounding to the nearest meter, it's 3 meters. Whereas if you had 3.5 and you're rounding it to the nearest meter, it goes up. So the 30 minutes is half of the degree. So you now change anything that has got minutes of 30 to 59, you change the degrees. So in our first example, 37 degrees 29 minutes is rounded to the nearest degree to be 37 degrees. Whereas 21 degrees 30 minutes is rounded to 22 degrees because the 30 minutes is past halfway. Now, you can get the pattern on this, that when you're rounding angles to the nearest minute and you're looking at the seconds, no seconds to 29 seconds don't change the minutes. 30 seconds to 59 seconds changes the minutes. So 57 degrees, 49 minutes, 25 seconds is rounded to 57 degrees, 49 minutes. The 25 seconds don't change the degrees. Whereas if I've got 23 degrees, 15 minutes, 38 seconds is greater than 30, so it's rounded to 23 degrees, 60. So let's take a look at degrees, minutes and seconds on your calculator. Generally speaking, the button has got all three symbols on it. So it looks something like this. This button will switch you between degrees with a decimal to degrees, minutes and seconds. And if you press it a second time, it goes back again. So if you were to put into your calculator 52.63 degrees, this will go to 52 degrees, 37 minutes and 48 seconds. Press it a second time and it goes back to 52.63 degrees. Now let's take a look at problem solving using trigonometry. The most important step in the process is to identify the correct ratio by positioning the H, the O and the A for the angle that you've got. Okay? Get the first point, get the ratio right, and you'll find that there's only three types of problems. So let's take a look. It's very, very simple. So we're going to be looking at now the two types of problems where we've got two sides. Types of problems. Unknown numerator. In other words, it's on top. So in sine, it's the O that's unknown. Cos, it's the A. And tan, it's the O. So we're looking at unknown numerator. Identify the H, the O and the A for the angle you've got and work out which ratio to use. So here's our problem. We've got an angle of 35 degrees, and when we look at our diagram, we've got an H, which is the 17, and the A, which is the X. So that's the one we're trying to find. So if we've got A and H, so car, C-A-H, so it's cos. So using cos, we have cos of 35 degrees is X over 17. Now you know if we're trying to solve this sort of equation, and you've got X divided by a number, multiply both sides by the number that's underneath the X, and you find out what the value of the X is. So in this case, we see that X is going to be 17 cos 35 degrees. This is great. Now just use your calculator. And we find that in this case, X is 13.9 centimetres to 1 decimal place. It's important for you to go through the full 3 steps. Write down the ratio, start there, then manipulate it. So we get, in this case, x is 17 cos 35 degrees. Use the calculator, you're at the answer. So, let's go through unknown numerator. If you've got sine, then sine's used in each step. If you've got cos, then cos is used in each step. And if you've got tan, then tan is used in each step. Let's consider the following. And I'm going to do 3 problems here using one with each of the ratios. And you can see that the process is identical each time. So in the first one, we've got 35 degrees. Relative to that, we've got the O, which is the x, and the h, which is the 10. So for O and h, we're going to use sine. In the second one, we've got a y is an a for the 47 degrees is the our angle, and h is the 15. And in the last one, we've got 7 degrees is our angle, q is the o, and 150 meters is the a. So in the first one, we get sine of 35 degrees, sine of the angle, is x over 10. Second one, cos of the angle, cos 47 degrees, is y over 15. And in the third one, tan of 7 degrees is q over 150. We now manipulate it. We get rid of the numbers on the bottom and bring it to the opposite side. So in the first one, we have x is 10 sine 35 degrees. In the second one, we have y is 15 cos 47 degrees. And in the third one, we have q is 150 tan 7 degrees. So now, oh, look at that. We can just use the calculator. Use the calculator. We find in the first problem, x is 5.74 centimeters. Second one, y is 10.23 meters. And in the third one, q is 18.42 meters. 3-step process. Let's go back to our types of problems. Again, we're looking at sides. Here we're looking unnamed denominator. In other words, denominator is the thing on the bottom. So in sine, we've got the h that is missing. With cos and tan, we have h with the cos and a with the tan. So, unknown denominator. Identify the h, the o, and the a for the angle that you've been given. That's the first step. So here's the diagram we have this time. We've got 35 degrees. Relative to that 35 degrees, we have a 67, which is an a, and an h, which is y. So with a and h, so car, we're going to use cos again. So, cos 35 degrees is 67 over y. Now, as I said before, when you've got a number underneath, and y is going to turn out to be a number because it's a length, we're going to multiply both sides by that y. So we get y cos 35 is 67. Now, cos 35 is a number. So therefore, we've got y cos 35. If I had 3y is equal to 15, you'd say, well, divide both sides by 3, so y is 5. So cos 35 is just a number, so we're going to divide both sides by cos. We're going to get y is 67 over cos 35. Simple. Use calculator, and we find that y is going to be 81.79 centimeters. That's it. So, we're going to go through the 3 problems, and I'll show you how it's an identical process for each. So here's our 3 diagrams. In the first one, we've got 83 degrees, and relative to the 83 degrees, we've got an O and an H. O and an H is sine. In the second one, relative to the 36 degrees, we've got a 30 and a K, an A and an H. So that's going to be cos. And in the last one, no prizes for guessing this one, you've got an O and an A, so this is going to be tan. So step 1, write down the ratio that's relevant for the problem that you've got. So our first one says sine of 83 degrees is 12 over A. In the second one, it's cos of 36 degrees is 30 over K. and tan of 3 degrees 16 minutes is 75 over P. Take the next step. A sine 83 degrees is equal to 12 in the first one, K cos 36 degrees is equal to 30 in the second, and P tan 3 degrees 16 minutes is 75 in the third. Now we divide by the sine, cos and tan for each of the individual problems. So in the first one, A is going to be 12 over sine 83. Second one, K is going to be 30 divided by cos 36, and P is going to be 75 divided by tan of 3 degrees 16 minutes. Use the calculator, and you find that in the first one, A is 12.09 meters, K in the second one is 37.08, and in the third one, P is 1,314 meters. Okay, now you won't be required to do 3 problems at a time. What I'm trying to show here is, if you understand the process, it's the same for sine, cos, and tan. Now there's another little secret for you. What you'll find, you don't have to put the next step in. That second step, where I flip it around, you don't have to put it in. If you want to, you can. You don't have to. So you can go from something like sine 83 degrees is equal to 12 over A, and you're basically swapping the A and the sine 83 degrees over. Ooh, looks like I've lost my degrees sign on the 83 and that second step, but who cares? And then you just use the calculator. So unknown denominator. If you've got sine, then use sine in each step. If you've got cos, then cos in each step. And if you've got tan, tan in each step. So you can understand the importance of identifying the first ratio correctly. Write it down and then work from there. That ends the video on having 2 sides unknown. There's only 2 possibilities, numerator and denominator.